In this video, we're going to start talking about equations that have more than one variable. Actually, equations that have two variables. We have two variables. We're no longer in one dimension, but we're in two dimensions or multiple dimensions here. And so when we think about things, we have to think of them not just on a number line, but in our XY plane. And so when we think about equations that have two variables, generally they have infinitely many solutions. And the solutions to equations that have more than one variable or two variables are ordered pairs that you can substitute one coordinate into one variable, the other coordinate into the other variable, and this to satisfy that equation, right? So that we can actually see all of our solutions or a visual representation of our solutions, we actually usually graph these equations. And so the purpose of graphing one of the purposes is to visually represent all of the solutions. And we graph in our XY plane, which is what we usually call it, but it's your Cartesian coordinate plane or your rectangular coordinate plane. Those are some other terms that we use for that. Remember, your x-axis is always your horizontal axis, your y-axis is always your vertical axis. And so if we have a xy plane, it looks like this. It's just two number lines that intersect each other, right? And the point of intersection is called your origin, which is the point 0, 0. Your positive y values are here. You can continue there. Your negative y values are there. Your positive x values are normally to the right of 0, and your negative values are to the left of 0, right? So that's our rectangular coordinate plane. The two number lines that make up your rectangular coordinate plane create four separate regions called quadrants. So this is quadrant 1. Here we have quadrant 2, quadrant 3, and quadrant 4. And to get to points within your XY plane, in your two-dimensional space here, we use ordered pairs, one that represents the value relative to your x-axis, and then one representing the value relative to your y-axis. So any ordered pair can be plotted in your XY plane as such. And so what we're going to do is we're going to get used to some of the properties or some of the way that this coordinate system works, and then we'll get to some equations, right? One of the formulas that's very interesting and one that we want to know is the distance formula. So if you have two ordered pairs, one that we'll call x1, y1, and the other which we'll call x2, y2, because they're x and y's. And so to tell the difference between the two, we're going to put a subscript on there. All right, this means that this has an x coordinate of x1 and a y coordinate of y1. And this one, if I think about my x coordinates, about right there, so I have x sub 2, and my y coordinate is over here, y sub 2. And then if we want to find the distance between those 2 points, is basically the length of the line segment that has those two endpoints. I know that's supposed to be a straight line, but there we go. And so what we can do here is we can actually use the fact that we're in a rectangular coordinate system, and I'm actually going to be smart here, and we could graph or create a figure, this is so cool, that looks something like this, which we would call a right triangle, right? And so it is a right triangle because we're in a rectangular coordinate system. So all horizontal lines and vertical lines meet at right angles. And so I drew a vertical line that has the same x value. So this point will have the same x value as x2. And this point right here will have the same y value as y1, right? So if I wanted to know the ordered pair for that point there, but the distance, which we want to call d here, between those 2 points is the length of this line segment. We have a right triangle. This is a leg, and this is the hypotenuse, right? Now the Pythagorean theorem, we know that d squared, the length of this line, if I square that, it should equal the square of this side right here. Well, if I think about the length of this side, it's going from x1 to x2. And so what I'm going to do is say that it is the absolute value of x2 minus x1. All right. And then the So that would be the absolute value of x sub 2 minus x sub 1 squared. And I use absolute values because it represents the distance, and distance is always positive. Now, I chose x2 to be to the right of x1, so it doesn't really matter. But in general, we want to use absolute values to make sure that it's positive. And then, so that's one leg. My other leg is over here, and it's basically this height right here, which is as high as y2, and it stops at y1. So that would be the absolute value of y2 minus y1. Again, y2 is higher than y1, but to make it generic to work for any y1 and y2, then we put it in absolute values, right? Well, the absolute values really don't matter because we're squaring this. So whether it's positive or negative, we're going to get the same outcome. So we can actually remove those absolute values here. All right. So sometimes in math, we try to be extra careful here to make sure that things always work. And then some nice things that happen, like in this case, we don't need the absolute values there. But the distance squared is the square of this side length plus the square of that side length. Again, that's by the Pythagorean theorem. And so if I want to know the distance, all I have to do is take the square root of both sides. Remember, when we take the square root of both sides, we usually put plus or minus, but this represents a distance, and distance is always positive. So I'm not going to put the plus or minus here. But there we go. We can find the distance between these 2 points here, especially when we have a line that's not horizontal or vertical, it's diagonal, right? We can also find the midpoint between 2 points in our xy plane. So if we have these same 2 points, x1, y1, and x2, y2, if I want to find the midpoint, which is the line segment that's right, or the point that's right in the middle of that line segment, right? All I have to do is basically take the average of my x coordinates, right? So if I do x1 plus x2 and divide that by 2, I should get the midpoint there. So that would be x1 plus x2 over 2, right? And then this y coordinate will be directly in the middle of these y values, which is the average. And so I can do y1 plus y2 over 2. And so notice this is our midpoint, which is a coordinate, right? So your distance is an actual number, but the midpoint formula gives you the actual coordinates of the point that's in the middle directly between those 2 points, right? And so it's an ordered pair. It's x1 plus x2 over 2 comma y1 plus y2 over 2. Let's look at an example where we use these to find the midpoint and the distance between points. The 2 points I'm going to be interested in here are -3, -2, and the point 9, 3. And so if I want to find the distance, I can label this point here x1, y1, and this one here x2, y2. And so when I do my distance formula, by the way, I always write, when I'm learning formulas, I always write them out until I have them memorized, right? And so since I made an error. So until I memorize this formula, I'm going to write it out each time, even when I'm doing my homework problems. All right. So my x2 minus x1, that'll be a 9 minus a -3 quantity squared plus a 3 minus a -2 quantity squared. Well, 9 minus -3 is 12, so that 12 squared is 144. 3 minus -2 is 5. 5 squared is 25. And that's the square root of 69, which is 13. My midpoint, the midpoint of the line segment that's joining those 2 points, I find the average of my x and y average of my x and y coordinates, right? So I do a -3 plus 9 over 2 and a -2 plus 3 over 2, right? And so I get a 6 over 2, which is 3, 1 over 2, which is 1/2. And so I found the distance and the midpoint of the line segment connecting those 2 points. The equation of a circle, all right, that's another interesting thing that we can get from this stuff here. A circle consists of all points that lie in equal distance from a given point in the plane, right? So if I have a point in my XY plane, okay, and I want the set of all points that are equal distance from that point, right? So this point that I'm having here is called our center. And if I pick an equal distance that I want all the points in my plane to be in reference to that center. So let's say I want them to be that distance there. Then the circle is basically all the points that lie equal distance, and that equal distance is called your radius. And so what we want to do is we want to come up with the equation of this circle here, all the points that lie equal distance from that center, right? And that equal distance is r, your radius. And so we're going to come up with the equation of the standard equation of a circle. It says let your center be given by hk. So my center maybe about right here. The coordinates of that are hk, and my equal distance is my radius, which is given by this right here, which is r. Now we want an equation. All our equations have an xy in them. I'm just picking a random xy, which is this one here. And so remember, we have our distance formula here, which is the square root. Actually, without going over the distance formula, I'm going to go back to our Pythagorean theorem, right? I think I like that better, right? By the Pythagorean theorem, what we can do once again, and I like the fact that I can create these lines now, learn something new every day. Then I know that I can create a right triangle. Okay, it's not going to be perfect, right? And from my right triangle, I know that if I subtract my x coordinates, right? So this side length here is the absolute value of, all right, I subtract my x coordinates because this point right here is the point x and it has a y value of k. So I subtract my x values here. So this is h, this is x, so that'll be x minus h. And my y values here, this one has a y value of k. Here my y value is y. And so this distance over here is the absolute value of y minus k. And so by the Pythagorean theorem, I know that if I square my hypotenuse, that should equal the sum of the square of my legs. So I get the absolute value of x minus h squared plus the absolute value of y minus k quantity squared, and that's going to equal the hypotenuse squared, which is r squared. Again, I don't need the absolute values because I'm squaring these terms. And so here we get the equation of our circle is x minus h quantity squared plus y minus k quantity squared equals r squared. And so if I give you an example, an equation, so let's look at an example here where we find the equation of, nope, we're not going to find the equation, find the center and the radius of the following circle. All right, and this circle is going to be given by this equation here, x minus 5 squared plus y squared equals 17. All right, well, it's x minus h. So your center is always given by hk. All right, h is whatever value is subtracted from x. Well, what's subtracted from x here is 5. K is whatever is subtracted from y. Well, it doesn't look like anything is subtracted from y. So 8k equals 0. So my center is the 0.50. My radius is always sitting here squared. Well, my radius squared is 17. So if I want just the radius instead of the radius squared, I have to take the square root of that value, which is the square root of 17. So this circle with this equation has a center of at the point 50, and it has a radius of the square root of 17. All right. In example 2, we're going to write the standard form of the equation of a circle with the center at the point -3,9 that passes through the origin, right? So the standard form, again, I'm going to write it down every time I see a problem that involves a circle. I'm going to write down the entire equation until I memorize that equation there. And I know the center, right, is -3,9, but I don't know the radius. So we want to find the radius in order for us to have the standard form of the equation of the circle. So since they don't give us the radius, they give us some information in order to help us find the radius. And this is the information that they give us. We know that it passes through the point 0, 0, right? That means if I plug in x equals 0 and y equals 0, I'll have my equation of, I know that it satisfies my equation of my circle. That is the information we're going to use to help us find out r. And so I'm going to put 0 in for x, -3 in for h, 0 in for y, 9 in for k, and that gives me an equation with just r. Now, this negative 3, if I square that, I'm going to get 9. Negative 9 squared is 81. So I get r squared equals 90. Now here, all I need is r squared. So I'm not even going to take the square root to find r, because in my equation of my circle, which is this equation here, all I need to do is substitute this value in, and that thing in, right? So my equation of my circle is going to be x minus a negative 3 quantity squared plus y minus 9 quantity squared, this is coming from my center, equals r squared, which we just found was 90. All right. Now, I don't like this minus a negative 3, so that would be an x plus 3 squared plus y minus 9 squared equals 90. Notice here, when my if either h or k are negative, it's going to appear as a plus sign in my equation here, right? So be careful. Remember, h and k are the actual values that you subtract. And so if you see a plus sign, what you're actually subtracting is a negative. People can get mixed up with that quite often. All right. Find the center and radius of the circle given by the equation here. I have x squared minus 8x plus y squared. Let's change this up ever so slightly. We're going to change this up in this manner here, just to make it a little more difficult. We're going to say plus 9y equals 5. Now, remember, our equation of our circle is x minus h quantity squared, y minus k quantity squared equals r squared. That's not what we have here, right? One of the things you have to notice is that both of these are perfect squares, right? What we have here and what we have here are quadratic expressions, right? And so when we have quadratic expressions and we need to get a perfect square, we use completing the square. So what we're going to have to do is complete the square on x and y here, right? And so remember, when we complete the square, we add b over 2 quantity squared, right? But we have to complete the square here, and we have to complete the square here, right? I'm going to use a different color when I complete the square for y. All right, so I'm going to add my b over 2 squared for my x's. Notice in the place of b is negative 8, so I do negative 8 over 2 squared, which is 16. And when I go to my y, that's going to be a 9 over 2 quantity squared. Well, that's just 81 over 4, right? And so what I'm going to do is I'm going to go back to my equation and I'm going to add those values. Now, I'm going to add them in the places that I need them. Like, for instance, I need to add the 16 here. And then for my y squared plus 9y, I'm going to have to add my 81 over 4 here. Now, I added this and this on my left-hand side. I have to add it to the right-hand side as well in order to keep my equation balanced. Now, this looks like a lot, right? But we're going to look at these independently. All right, I'm going to factor these, and when I factor this one, I'm going to end up with an x minus 4 quantity squared, right? 4 is the number that if I multiply it by itself, I get 16, and I add it together, I get negative 8. And when I go to my y's, the number that I multiply by itself to get 81 over 4 that I add together to get 9 is sitting here, 9 over 2. And this will be a 21 plus 81 over 4. Remember, 21 is the same thing as 84 over 4. And so if I wanted to write my equation, it's going to be an x minus 4 quantity squared plus a y plus 9/2 quantity squared. And that's going to equal 84 plus 81, which is 165 over 4, right? And so here I can see that my center is the value that I'm subtracting from the x, which is 4. And this is the value that I'm subtracting from the y, which is a negative 9/2. And our radius is, well, it's sitting here squared. So if I take the square root of that, I'm going to get the square root of 165. And the square root of 4 is 2. So I have the center and radius of that stuff there. All right. The last thing we want to talk about here is equations of lines. We're going to have a whole section on equations of lines. There are actually more formulas for that, but this is the standard form of the equation of a line. 8x plus by equals c, where A, B, and C are real numbers and A and B are not both zero, right? So if A and B are both zero, I don't have any variables in my equation anymore. So it's not going to be an equation of interest, right? Now, one of them can be zero. For instance, if A was zero, I will only have an equation with Y. It'll be a single variable equation, right? When that is the case, we have a horizontal line, right? When B equals zero, then the only variable that's going to be in my equation is going to be X. And when X is equal to some number, then it is a vertical line. But in general, we have an equation like 2x minus 3y equals 4. This is an equation, a linear equation. It's linear because both variables are to the first power, right? So when both variables are to the second power, and we have a leading coefficient of 1 here and a leading coefficient of 1 here, then it is an equation of a circle. But when our variables are both to the first power, then we have a linear equation, okay? Your x-intercept and y-intercept are properties that properties of graph that may be interesting and may help you graph. Your x-intercept is the point where your graph crosses or touches the x-axis. So remember, any point on your x-axis, for any point on your x-axis, they all have y coordinates of 0, right? Y always equals 0, right? That's always the case. And so since that is the case, we can use that to help us find out what our x-intercepts are, right? We just set y equal to 0 and solve for x, because that's the only way for us to cross or touch the x-axis is for y to equal 0. The opposite thing happens when we look at y-intercepts, right? Any point on our y-axis has an x-coordinate of 0, right? That means x equals 0 always. And so if we want to find our y-intercept, we set we just said x. You set x equal to 0, and then we solve for y, okay? And so we're going to look at this example of this linear equation in two variables. Let's find our x-intercept. Then we're going to find our y-intercept, and then we're going to use that to help us graph, right? So when you're finding your x-intercept, let y be 0 and solve for x. That's 5x equals 12, or x equals 12 over 5. And that's the ordered pair 12 over 5, comma 0. We find our y-intercept, we let x be 0. And so we get negative 2y equals 12, or y equals negative 6. And so we get the point 0, negative 6. And so we can use that information to help us graph. And I'm going to be clever here, and I'm going to create me an XY plane using this line feature. So excited about this. All right, it's not going to be perfect, of course. Okay, and so we can notate our X and our Y axes separately. Well, look at that, huh? So I'm going to put some arrows here. Uh-oh. Let's undo all of that. So we have our x-axis, we have our y-axis. They extend in both directions. So on my x-axis, I'm going to count by 1 because 12 over 5 is like 2 point something. It's probably like 2.4 or something like that. And on my y-axis, I'm going to count by 2s because I'm not going to have enough room to go. And so by knowing 2 points on a line, you can draw a pretty good graph of your line. That's a 4. And so the point 12 over 5, comma 0 is 2 point something. So I'm going to put a point there. And the point 0, negative 6 is this right here. So I'm going to put a point there. And basically, I want to draw a line that passes through both of those points, which looks like something like that. All right. And so this would be the line given by that equation there. All right, it's not perfect, but we can say that this is the equation 5x minus 2y equals 12. And technically what we're showing is all of the values of x and y, the ordered pairs together, that we should be able to plug into our equation and get a true statement out, okay? So that's finding the x and y intercept. Let's do this one here, right? Well, this equation here only has one variable, x equals 3, right? And so if I want to draw that equation, I got to remember, this is the set of all points in my xy plane such that x equals 3. Well, The only way for that to happen is for this line to be completely vertical, right? So if this is my x-axis, this is my y-axis, then the line x equals 3 looks like this, right? So to find your x-intercept, you can just look at that and tell that is x equals 3. And so you're going to get the point 3, 0. But what's true about horizontal and vertical lines, they don't have the opposite intercept, right? And so the y-intercept is not applicable, right? And so you only have 1 point if you try to use the x and y intercept when you have a vertical or horizontal line in order to help you get your line. All right. This concludes this video. We'll see you during the next video.